Welcome to the Indian Affairs Occupational Safety and Health Program, Common Electrical Hazards Training. This course provides an overview of electrical hazards commonly observed by occupational safety and health inspectors while conducting their mandatory annual OSH inspections. This course does not cover all electrical standards, only those most common to Bureau of Indian Affairs and Bureau of Indian Education facilities. The hazard information included in this course comes from recently issued hazard notices, the commonly found deficiencies list, and electrical hazards most frequently missed during inspections. Purpose: this course provides information and examples of commonly found electrical hazards in order to increase the OSH inspectors' awareness of these hazards and enhance their inspection skills. Photos are included to help OSH inspectors understand what incorrect installations look like and what correct installations look like. Hopefully, by identifying electrical hazards, the chance of employee shock or electrocution will be greatly reduced. Should the OSH inspector encounter electrical issues that have not been included in this training, they will have to do the research necessary to correctly identify and cite those hazardous situations. Guidebook: the Division of Safety and Risk Management, DSRM, has developed a reference for OSH IA Safety Connect that describes this information in detail. For specific information on National Fire Protection Association, NFPA, and Code of Federal Regulations CFR standards for each category, please refer to the Electrical Hazard Guidebook. These are 7 common electrical hazards found in the workplace. 1. Switches. 2. Receptacles. 3. Pull and junction boxes. 4. Electrical panels. 5. Listing and labeling. 6. Cords. 7. Lockout tagout. Grounded versus ungrounded light switches. Ungrounded light switches can work with incandescent lights. However, they present a potential shock hazard when used with fluorescent and LED light fixtures. Is this example switch correct or incorrect? This is incorrect because the switch is not grounded. Is this example correct or incorrect? This is incorrect because the switch is not grounded. This switch has a grounding screw, blue screw, but it's missing the ground wire. Is this example correct or incorrect? This is incorrect because the switch is not grounded. Is this example correct or incorrect? This is correct because you can see the ground wire attached to the green grounded screw. Covered versus uncovered. Uncovered light switches expose employees to electrical shock, which may be fatal. Are these examples correct or incorrect? These are incorrect because the covers are missing. Is this example correct or incorrect? This is incorrect because the cover is not flush to the wall. Is this example correct or incorrect? This is correct because the cover is installed flush to the wall. Metal light switch faceplates. Metal light switch faceplates require grounding in order to prevent potential shocks to employees. Is this example correct or incorrect? This is incorrect because the metal faceplate does not have a ground. Is this example correct or incorrect? This is a correct installation because the metal faceplate is grounded through the switch. Faceplates. Receptacle faceplates cover the electrical box and protect the wiring inside. Without the faceplate, exposed wiring increases the possibility of shorting and fires, as well as exposing employees to shock hazards. Is this example correct or incorrect? This is incorrect because the faceplate is missing. Is this example correct or incorrect? This is incorrect because the faceplate is broken. Is this example correct or incorrect? This is incorrect because the faceplate is not flush. Is this example correct or incorrect? This is an example of a correct installation. Metal faceplates. Metal receptacle faceplates require grounding in order to prevent potential fires and shocks to employees. Is this example correct or incorrect? This is incorrect because the faceplate is not grounded. Is this example correct or incorrect? This is an example of a correct installation. Damaged receptacles. Damaged receptacles can result in electrical shocks or fires. They can spark internally, increasing the fire risk, or live parts, such as wires or terminals, can create a shock hazard for employees. Is this example correct or incorrect? This is incorrect because the outlet is damaged. Is this example correct or incorrect? This is incorrect because the outlet is broken. Is this example correct or incorrect? This is a properly installed receptacle and has no damage. Receptacles in outdoor locations. Water inside a receptacle can be dangerous. Water conducts electricity, so a wet receptacle increases the possibility of an employee being shocked by coming in contact with water in or near the receptacle. Is this example correct or incorrect? This is incorrect because the cover is missing, exposing it to the elements. Is this example correct or incorrect? This is incorrect because it is not an approved outdoor receptacle. Are these examples correct or incorrect? These are examples of correct installations. Multi-plug outlet expander. Multi-plug electrical outlet adapters are often used in workplaces to expand plug capacity. They are prohibited because they can overload circuits and cause fires. Plugging in multiple appliances can generate enough heat to ignite combustibles before a circuit trips. Are these examples correct or incorrect? These are incorrect because they are not breaker protected. Is this example correct or incorrect? This is correct because the outlet is breaker protected, the switch on the left. Missing covers and canopies. Pull boxes, junction boxes, and fitting covers prevent employees from touching wire unions and potentially getting shocked. Are these examples correct or incorrect? These are incorrect because the covers are missing. Is this example correct or incorrect? This is incorrect because duct tape is not an approved cover. Are these examples correct or incorrect? These are examples of correct installations. Metal covers and canopies. Metal covers and canopies require grounding in order to prevent potential shocks to employees. Is this example correct or incorrect? This is incorrect because the cover is missing and there is no ground wire evident. Is this example correct or incorrect? This is incorrect because there is no ground wire. Is this example correct or incorrect? This is a correct installation because the cover is grounded through the box. Knockout. When not in use, openings in electrical boxes and cabinets must be closed to prevent the entry of dust, debris, and moisture. In addition, covered openings in electrical boxes and cabinets prevent potential shock risks. Are these examples correct or incorrect? These are incorrect because each round hole pictured, called knockouts, are not closed. Are these examples correct or incorrect? This is correct because the knockout hole is closed. The cover pictured on the right is used to close a knockout hole. Ungrounded pull and junction boxes. Pull and junction boxes require grounding in order to prevent potential shocks to employees. Are these examples correct or incorrect? These are incorrect because there is no ground wire evident. Is this example correct or incorrect? This is correct because the green ground wire is correctly attached to the box by the green screw in the back. Blocked panels. Working space allows employees room to work on electrical panels and move in case of emergency. Are these examples correct or incorrect? This is incorrect because the panels are blocked by equipment or debris. Is this example correct or incorrect? This is correct because the panel is not blocked and can be easily accessed. Unlabeled breakers. When electricity must be shut off, knowing each circuit's function in an electrical panel is crucial. During a fire, electrical short, or weather emergency, someone may need to quickly cut power, making electrical circuit identification essential. Is this example correct or incorrect? This is incorrect because the breakers are not labeled. Is this example correct or incorrect? This is correct because the breakers are labeled. Approval. The National Electric Code, NEC, and Occupational Safety and Health Administration, OSHA, require workplace electrical equipment to be certified by a nationally recognized testing laboratory, NRTL. After certification, manufacturers can apply an NRTL mark signifying compliance with safety standards. Is this example correct or incorrect? This is incorrect because the cover is not listed or labeled. Is this correct or incorrect? This is correct because it has an NRTL certification label with a listing on it. Shop-made extension cords. Shop-made extension cords are allowed only if they meet the same standards as factory-made, nationally approved cords. They cannot use boxes for permanent installations, must have strain relief, and require bushings or fittings when passing through enclosures. Are these examples correct or incorrect? This is incorrect because the devices are not used according to the listing or labeling. Is this example correct or incorrect? This is a correct use because the extension cord can only be used for its listing and labeling requirements. Daisy chaining. Daisy chaining interconnects extension cords or power strips, violating NRTL approvals. It increases resistance, generating heat and fire risk. The nearest power strip supplies more outlets than approved. Are these examples correct or incorrect? Plugging extension cords into other extension cords or power strips into other power strips violates the listing and labeling requirements. Is this example correct or incorrect? This is correct because equipment is not daisy chained and in accordance with the listing and labeling requirements on the tag. Fixed wiring. OSHA limits extension cords to temporary use for up to 90 days. However, they are often left in place longer, violating 29 CFR 1910.305 G14A. Permanent use can overload cords, creating a fire hazard. Is this correct or incorrect? This is incorrect because the extension cords have been in place too long and are now considered part of the building wiring. Is this example correct or incorrect? This is correct because the extension cords have been replaced by correct wiring. Routed through holes in walls, ceilings, or floors. Use extension cords only for temporary wiring. Never run them through walls, ceilings, or floors. Improper use can cause overloads and fire hazards. Are these examples correct or incorrect? These are incorrect. Extension cords are routed through walls and floors. Is this example correct or incorrect? This is correct because the extension cord is plugged into a proper outlet and not routed through walls, ceilings, or floors. Protecting extension cords from damage. Inspect extension cords before use to ensure they are undamaged. Protect them during use to prevent shocks, burns, and fires. Ensure strain relief is intact to safeguard internal wiring. Is this correct or incorrect? This is incorrect. The extension cords are damaged. Is this example correct or incorrect? This is correct because the extension cords are not damaged. Lockout, tagout. Controlling hazardous electrical energy prevents shock or electrocution during machine, equipment, or system maintenance. Proper lockout, tagout, LOTO procedures protect workers from dangerous energy releases. Is this example correct or incorrect? This is incorrect because neither panel is properly locked out or tagged out. Is this example correct or incorrect? This is correct. Improper use of lockout-tagout devices. Welcome to the course quiz. Why is it important for people who conduct safety inspections to be able to recognize electrical hazards? A. To ensure that walkways are kept clear. B. To reduce the chance of employee shock or electrocution. C. To make hazard notices longer. D. To ensure that fire extinguisher inspections are conducted monthly. E. All the above. The correct answer is B. To reduce the chance of employee shock or electrocution. This electrical hazard training covers all electrical hazards. A. True. B. False. B. The correct answer is B. False. It only covers common electrical hazards. Why is it a good idea to focus on the most common electrical hazards instead of all electrical hazards? A. To reduce the chance of employee shock. B. To reduce the chance of employee electrocution. C. The most common electrical hazards list covers the hazards a safety inspector will likely encounter. D. The most common electrical hazards list covers the hazards safety inspectors frequently miss. E. All of the above. The correct answer is E. All of the above. Standards allow electrical panels to be blocked. A. True. B. False. The correct answer is B. False. Electrical panels should be accessible. Where/when can extension cords be used? A. When power is required in another room, the regulations allow extension cords to be run through walls. B. When absolutely necessary, extension cords can be used for longer than 90 days as long as they are dry and protected from damage. C. When a building does not have power for lighting in necessary locations, extension cords can be used to provide power as long as they are hidden above the ceiling. D. Extension cords can only be used in a location where they can be protected from damage and for less than 90 days. The correct answer is D. Extension cords can only be used in a location where they can be protected from damage and for less than 90 days. Course Summary. This course was developed to provide information and examples of the most common electrical hazards that individuals conducting OSH inspections will likely discover. Photos were included to help OSH inspectors understand what incorrect installations look like and what correct installations look like. This should help increase inspectors' awareness of electrical hazards common to BIA sites, justice centers, as well as BIE schools in order to enhance their inspection skills. As mentioned earlier, please refer to the IA Electrical Hazard Guidebook for additional details and codes. Course complete. This concludes the IA Safety Training course for Common Electrical Hazards. Please proceed to the training course platform to complete the final test and confirm course completion. Thank you. Thank you.